The graph below shows the movement of a car of mass 1,000 kilograms over a period of 13 seconds. So this takes you 12, there's 13 seconds there. And this is a velocity time graph. I'll write that a little bit bigger. That's time. It says find the acceleration of the car between 0 and 4 seconds. Now, between 0 and 4 seconds there is this part of the graph, and again I'm aware that you may not see the 4 very well there. So this brings you up to 4 and this brings you up to 12. There's two ways you can do this. You can actually use the equations of motion, or you can find the gradient of the graph. So I'm going to just split this down, so give you the option of doing either. Again, you can stop the video and try and work that out yourself. So I'm going to do it with equations of motion. My initial velocity u is 0, the final velocity is 12, and the time is 4. So this is v equals, we're looking for a. So if we use v equals u plus at and rearrange it, this is just our definition for acceleration, v minus u over t. And that's equal to 12 minus 0 over 4. So it's really 12 over 4. So a is 3 meters per second squared. If we just do that with the gradient of the graph, a equals the rise over the run. The rise is 12 there. The run is 4. And the answer is, of course, 3 as well. And we would be worried if it wasn't. Find the distance travelled by the car between t equals 4 seconds and t equals 9 seconds. So this is something I didn't mention originally in the podcast, and I should have. That the distance, you can get distance from a velocity time graph if you get the area under the velocity time graph. So all velocity time graphs, if you get the area underneath, you've got the distance travelled. So we're going to just identify where that area is. Again, I'm aware you may not just see that too well. Maybe I'll just scan in a wee bit here and let you see that a little bit better. So we need the distance between time equals 4 and time equals 9. So we're looking between here. I'm going to draw a line in this graph. And time equals 9 is there. Now, we've really got three shapes there. We've got that shape there, and this shape, and then the little triangle there. So, if we do this shape first, we'll call it A. So the area of A is equal to, now that's a 7 there. So it is 3 times, and this is up at 12. So it's 3 times 12. And that gives you 36 metres. Okay. Just scan out a wee tiny bit so you can see it a bit better. The second shape we'll do is this one here. I'll call it B. And this time, the scale at the bottom is, it has a change of 2 and a height this time of, you can't see that again, I'm sure, that's 9. So 2 9s are 18 metres. And then our last shape is this C shape here. To get our C shape, we have to use the area of a triangle. So it's half the base for the height. The base, it goes from 7 to 9, which is 2, and the height goes from 9 up to 12, which is 3. So the answer there is 3. So the total distance then is 36 plus 18 plus 3. And that gives you a total distance of 57 metres. Right, next question, scan out again. Find the average speed of the car over the 13 seconds of its motion. So I'll just have to go back here to show you. So the average speed, we have to find the total distance over the total time. So this question's a wee bit more complicated than it looks. We've already found this bit, so we'll just find the last two bits here. The first one's a triangle here, and the last one is a rectangle. And so the first triangle there, we'll call it D. Half the base is 4 and the height is 12. So to find D is half the base, which is 4 by 12. And that gives you 2 times 12, which is 24 metres. And then which is this last one here. The time along the bottom is from 9 to 13, which is 4. And the time up here, the velocity up here is also 9. It's reading across as 9. So it's 9 times 4. And 9 fours are 36 metres. So your total distance is 57 from your last answer, plus 24, plus 36. And unfortunately, I still haven't got to our final answer. 117 metres, your total distance. Our final answer now is average speed equals total distance, which is 117, over the total time. And if I just go back, you can see the total time there is 13 seconds. So it's 117 over 13. And that gives you an answer of 9 metres per second. Is that answer? What is the resultant force acting on the car after t equals 9 seconds? Now that's a trick question, because if you have a look there, you can see the line is flat. You probably can't see it. You should be able to see it now. The line is flat. That means it's travelling at a constant velocity or constant speed, and therefore that's a question about balanced forces. And so you know the forces are balanced. If you have balanced forces, you have no resultant force. And therefore the answer is 0 newtons. The last question. The velocity time graph for lift as it moves from the ground floor to the top floor and back again is shown below. The portion OABC, so there's OABC, represents the motion of the lift as it ascends to the top floor. Describe the type of motion indicated by the lines OA, AB and BC. So OA, you can see it's going from naught up to here. It's a lovely straight line and it's an increase in velocity, so it's a constant acceleration. AB is a flat line, therefore it's a constant velocity. And BC is another nice straight sloping line, but it's going down the way. That means it's a minus acceleration or deceleration. So it's decelerating constantly. And it ends up at rest at C because its velocity ends up at 0. The last part of the question. So what is the distance between the ground floor and the top floor? So since the lift has moved from the ground floor to the top floor in this first little section here, then we have to find the area under the graph. And so we'll split it into 3 bits, a rectangle and 2 triangles, A, B and C. And B and C are exactly the same. So A, that goes from 2.5 to 7.5. That's a difference of 5. And it goes up to 3 here. So it's 5 times 3. So A is equal to 5 by 3. It gives you 15 metres. And then the next part, the 2 triangles there are 2.5 by 3. So B is 1/2 times 2.5 by 3. And so is C, 1/2 by 2.5 by 3. And that gives you 3.75 for both cases. So when you add those all up, you get a total then of 22.5 metres. The next question says, how long did the lift remain at the top floor? So if you have a wee look at the graph there, you can see that the lift is at rest between 10 and 20 seconds there. And that must be it at the top floor. So CD, the answer is 10 seconds. And why is the velocity of portion DEF negative? So think about this, what happens here. It's accelerating, constant speed, decelerating, and it's at the top floor. Remains there for 10 seconds. What's it going to do? Well, it can't go any further. It must come down the way again. And therefore, it's moving in the opposite direction